Right, here we have quiz on polynomial 1, and there are 3 questions that you need to be focused on, particularly on the last two, question 13 and question 15. Let's go. In this question, in question 8, we want to find which of these 4 options are actually factors of this polynomial. And you have to apply the factors theorem, because if it's a factor, then the remainder must be 0. So we'll try out on every one of these. So let's let P of x be the polynomial. And the first option is A. Now here, we could imagine thinking that x minus 3 is equal to 0, because if it's a factor, then part of that, it makes off as the polynomial part. So so we can think that way, but be careful how you write it, okay? So imagine that x minus 3 is equal to 0, so x is equal to 3. So we substitute x is 3 into the polynomial P of x. Well, obviously, we see that the value is minus 96, so A is not one of the factor. Let's try B. So now we substitute x as minus 4. Now the polynomial is equal to 0. So according to the factors theorem, actually B, x plus 4, is a factor. Now, question 13, you have to be very familiar with the format of a polynomial, which is a polynomial is equal to a divisor times the quotient plus the remainder. Now note here, in our question, we're told that the remainder is of this, has got x in it, as well as got minus x plus 5. Which is not a normal type, and we consider R as often as constant. But actually, it doesn't have to be constant, because that depends on the degree of the polynomial of the divisor, as you will see later on. So what I'm going to do is let this R be R of x, so like a function of x. Now if you consider the example here on the left, when I divide into here, my remainder here is x minus 1. Now the reason for that is because x squared plus 1 can no longer divide into x minus 1. So the remainder is not a constant itself. Actually, it is off in terms x. So sometimes the remainder could be in terms of x. Now the polynomial is equal to the divisor times the quotient, which is x, plus the remainder, which is x minus 1. So that's what it means when we see a remainder that is of minus 2x plus 5. So it can be of this. So now let's find the remainder when f of x is divided by x plus 3. So let's put that into our expression. So f of x is of this. So it's equal to a divisor times the quotient with the remainder. Now you can see that the divisor can be further factorized. And part of that is x plus 3. Now, if the divisor from the earlier part, which generates a remainder of minus 2x plus 5, on part of that is actually x plus 3. And the other part is of x minus 4. So what we consider is that if x plus 3 is part of making of the divisor, then we could also consider that the x plus 3 can be of similar, that can generate a remainder. So we consider that x plus 3 is equal to 0. Now we put x is equal to minus 3, and our remainder function is of 2x plus 5. Put x equal to minus 3 into it. And the remainder here is 11. Now there's a lot of concept in here, it's quite challenging as well. So if I quickly walk through this again, we first have to consider the function, in this case the polynomial of f of x, and we use the format as of the divisor times the quotient plus the remainder. And often the remainder is a constant, but it doesn't have to be. So in this case it is not a constant, it's of minus 2x plus 5. So we see that here the format for our polynomial now becomes this. Now we also see that part of the original divisor can be further factorized, and this here is part of the original divisor. And if it's part of the original divisor, when we divide it by this part of it, according to the remainder theorem, P of A here actually is the remainder by substituting a suitable value of A into the function. And in this case what we have is of x plus 3. So if I let x plus 3 and consider it to be equal to 0, then the A is of minus 3. Now in here we're not talking about the polynomial because we're focusing on the remainder. And the remainder here in this case is of r of x. So putting x is equal to minus 3 back into our expression for the remainder, hence we get 11. And that is the remainder if we divide it by x plus 3. Now in this question 15, again, there are a lot of concepts involved in here. So if f of x is divisible by x minus 2, what does that mean? Well, this means that if we put x equal to 2 into the function, then the remainder should be 0. So we could apply a factor theorem here, and f of 2 is equal to 0. Now the question here is, what is f of x plus 1 is divisible by? Now if we consider the f of 2 is equal to 0, then if f of x plus 1, and that x plus 1, if I could make it into 2, then obviously that will also be 0, have a 0 remainder. Because if f of x plus 1, if x plus 1 is equal to 2, then we have a 0 remainder. Hence, in this case, x minus 1 is equal to 0. So the factor here then will be x minus 1. So it should be minus 1. Okay? Right, so the answer here is A. Thank you for watching. Take another look. And I'm sorry about the last one. There should be a minus here. Okay? Well, bye for now.